Welcome back, everyone. Robotics in construction is no longer a far-off concept. Around the world, large automated machines and mobile robotic systems are entering building sites with the promise of transforming how quickly multi-story homes can be completed. These machines range from massive frame assembling gantries to smaller autonomous units that transport materials and perform precision tasks. By integrating advanced software for design interpretation, these robots can follow complex architectural plans without the delays and inconsistencies that sometimes come with manual labor. The result is a pace of work that was once unimaginable in residential building projects. Some systems can even make on-the-spot adjustments if site conditions change, allowing the project to stay on schedule and maintain high accuracy. In current pilot projects, robot crews are assembling entire structural frameworks in just a few days. These systems work continuously, with no need for breaks, while sensors and AI-driven monitoring ensure that every element is aligned to exact tolerances. Walls, floors, and even roofing segments can be prefabricated and installed rapidly, with the robots coordinating movements to avoid collisions and optimize workflow. Human operators remain on site, but their role is shifting from physical construction to supervising the machines, checking quality, and resolving issues that require adaptive decision-making. This combination of precision automation and human oversight is changing the role of construction teams, with some projects reporting reductions in total build time by as much as 70% compared to traditional methods. One of the breakthroughs making this speed possible is modular automation. Robots can handle large prefabricated components, positioning them with millimeter accuracy, then securing them using fasteners or automated welding systems. This process eliminates the need for extensive on-site measuring and manual adjustment. In some cases, entire sections of plumbing and electrical wiring are integrated into the modules before they arrive, reducing the number of steps needed on the construction site. Once the main structure is up, smaller robots can handle interior work, such as insulation placement, drywall installation, and even painting. The sequence is carefully choreographed by central control software, which can be monitored remotely, allowing specialists to oversee multiple sites from a central office and respond quickly to any technical issues. Construction robots also bring new safety advantages. Tasks that involve heavy lifting, work at dangerous heights, or exposure to hazardous materials can be performed entirely by machines. This reduces the risk of injury for human workers, which has been a long-standing challenge in the industry. Cameras, LiDAR sensors, and environmental scanners keep track of surrounding activity, ensuring the robots operate safely even in mixed environments with people nearby. The systems can detect sudden changes, such as a person entering a restricted zone, and pause operations instantly. Safety protocols are built into every stage of the process, and in some cases the machines can send automatic alerts to supervisors if unusual movement or vibration is detected in the structure being assembled. The speed at which these robot crews operate comes from a combination of mechanical endurance and digital coordination. Instead of separate teams working in sequence, such as foundation crews, framing crews, and finishers, robots can work in parallel. While one machine lays floor panels, another can be installing walls, and yet another can be handling roof segments. Software keeps the tasks synchronized so that progress is steady and without idle time. This parallelization means that multi-story homes that once took months to complete can now be built in a matter of days. In high-demand markets, this can mean that developments of dozens of houses can be completed in the time it used to take to finish just a few, offering a major competitive edge for builders. Beyond speed and safety, robotic construction offers remarkable consistency. Every cut, joint, and fastening is performed exactly as programmed. This reduces waste, since fewer materials are discarded due to errors, and results in tighter fitting components that improve the overall structural integrity of the building. For example, walls assembled by robots are less likely to have uneven surfaces, which makes later tasks like installing fixtures and cabinetry faster and easier. Over time, the consistent quality delivered by robotic systems could redefine building standards and inspection processes. Consistency also reduces disputes between contractors and clients, as the finished product matches the agreed design more precisely, lowering the likelihood of costly rework. In urban areas where space is limited, these systems can be particularly effective. Compact, mobile robots can operate within tight plots of land, lifting materials with precision in locations where large cranes cannot fit. Automated planning tools can generate the most efficient paths for each machine, reducing unnecessary movement and minimizing disruption to surrounding areas. This allows construction to proceed in dense neighborhoods with less noise and less interference with pedestrian and vehicle traffic. The ability to build multi-story homes in such environments opens new opportunities for urban housing development, particularly in areas where demand is high but available land is scarce. Some projects have even been able to complete builds without fully closing nearby streets, keeping neighborhood activity largely unaffected. There are already examples of robotic crews completing projects under some really challenging conditions. Some have operated in extreme temperatures, while others have handled construction in regions where traditional labor shortages have delayed projects for years. In each case, the robots are adapted to the local environment through adjustments in programming and hardware. For instance, in hot climates, components are designed to resist heat stress, while in colder regions, systems are insulated to protect sensitive electronics. These adaptations allow robotic systems to work reliably almost anywhere. A notable example comes from a coastal region where machines built elevated homes designed to withstand flooding, completing them weeks faster than expected despite challenging weather. While these systems are advancing quickly, they do not eliminate the need for skilled human workers. Instead, the nature of those skills is shifting. Operators must understand how to program and maintain robotic systems, interpret sensor feedback, and make decisions when unexpected situations arise. This has created a demand for training programs that teach construction workers how to transition into supervisory and technical roles. Over time, entire career paths in construction will be defined by the ability to work alongside automated systems, much like how industrial automation transformed manufacturing. Companies that invest in this training are finding that their workforce adapts more quickly and is able to operate more efficiently with the new technology, leading to smoother project timelines. One of the most impressive features of robotic construction systems is their ability to integrate with digital design workflows. Architectural plans created in CAD software can be transferred directly to the robot's control system, eliminating multiple steps of manual translation. This reduces the risk of misinterpretation and speeds up the start of construction. In addition, simulation tools can model the entire building process before the first material arrives, identifying potential problems in advance and optimizing the construction sequence. This digital twin approach allows project managers to explore different build sequences and choose the one that will save the most time without compromising quality, giving them the ability to make data-driven decisions before work begins. Despite the rapid progress, challenges remain. Robotic systems require significant initial investment, which may be difficult for smaller construction firms to manage. Maintenance is another concern. While robots can work continuously, they must be serviced regularly to avoid downtime. The supply chain for specialized parts and software updates must also be maintained. Furthermore, local building codes may need to be updated to account for new construction methods, particularly in regions where regulations are slow to adapt to technological change. Some jurisdictions are already creating guidelines for automated construction, but in others, the approval process still assumes human labor for key steps, which can slow adoption. Looking ahead, the expansion of robotic construction is likely to be supported by ongoing advances in materials, science, and energy systems. Lighter, stronger building materials will reduce the strain on robotic arms and lifts, while improved battery technology will allow mobile robots to operate longer between charges. Solar-assisted power systems and regenerative braking for large machines could further increase efficiency. These improvements will make it possible for robots to handle an even greater range of construction tasks without interruption. New developments in composite materials may also allow for prefabricated sections that include insulation, wiring, and finishing layers in a single unit, streamlining the process even further. For residential developers, the appeal of robotic construction crews is clear. Faster build times mean quicker sales and reduced carrying costs for projects. Consistent quality reduces warranty claims and improves customer satisfaction. In areas with high demand for housing, being able to deliver homes in a fraction of the traditional time could transform market dynamics. Municipalities may also benefit from faster housing availability, helping to address shortages in growing regions. In competitive markets, developers who adopt these systems early may be able to secure more contracts and position themselves as leaders in modern building techniques, gaining a long-term advantage. We are now seeing the beginnings of a new phase in construction, one in which the traditional image of a building site full of manual labor is replaced by a coordinated team of robotic systems working with precision and speed. As these technologies become more affordable and widespread, they have the potential to redefine what is possible in residential construction. It is a future where building multi-story homes in days is not an exception, but the standard pace of the industry. Thank you very much for watching. Please like and subscribe.